What Professor David MacMillan and I have discovered in around the late 90s was that there is a third class of catalysts available with which we can make all these molecules that we need, like drugs and scent molecules, but also plastics, pretty much everything that surrounds us. And the new class that we discovered are organic molecules. Before we thought there were only enzymes and transition metal complexes that can be used as catalysts. And we found simple, small organic molecules that you can isolate from natural materials. And some we even make in our own body, like the amino acid proline, which we used as a catalyst. And that was really a shock even to us at the time. And yeah, that was our discovery. Most use of our technologies are in the synthesis of small molecule drugs, pharmaceuticals. These are often relatively complex molecules, and the synthesis is not so easy. And our catalysts specifically help, for example, in the preparation of one antiviral compound. And I think this is a good time to remind people how important antivirals are. I mean, everybody is now aware of that fact, right? We think vaccines are the cure, and often they are. I think in this current pandemic, for example, it's a vaccine. But in many other diseases, like for example hepatitis C or HIV, it's small molecule drugs that chemists design and synthesize. And one particular drug is made using organocatalysis, and actually it's currently used everywhere in the pharmaceutical industry. I still think that it could have an impact. Like, imagine there's a small molecule drug, then you take and you simply don't end up in the hospital. I think that would really change this pandemic completely, right?
And is that something that could happen with
absolutely. Absolutely. I mean, we are not working on drugs. We're making drugs, right? So it's a slightly different angle. So it's the technology with which you can make drugs. It's not the design of drugs, what we do in our lab.